For decades, we've searched the cosmos for signs of intelligent life. We've listened, we've sent messages, and we've found nothing. But what if the answer to one of humanity's greatest mysteries is surprisingly simple? A NASA scientist has just proposed a theory that might disappoint science fiction fans everywhere. Aliens might just be too lazy to contact us today. We're diving into the theory of radical mundanity and what it means for our search for extraterrestrial intelligence. First, let's talk about the problem. The Fermi paradox, named after physicist Enrico Fermi, asks a simple but profound question. Where is everybody? Our galaxy contains over 100 billion stars, many of which have potentially habitable planets. Even if intelligent life is rare, the sheer number of stars suggests we should have detected something by now. Scientists have proposed numerous explanations. Perhaps civilizations destroy themselves. Perhaps they're hiding from us, or perhaps interstellar travel is simply impossible. But Dr. Robin Corbett from the University of Maryland and NASA's Goddard Space Flight Center has a different idea, and it's refreshingly boring. Corbett's theory is based on what he calls radical mundanity. The idea that the most boring, ordinary explanation is probably the correct one. Instead of galaxy-spanning empires and fleets of interstellar probes, Corbett suggests that most alien civilizations simply plateau at modest technological levels. Think about it. Achieving interstellar travel would require enormous resources, time, and risk. And for what? Corbett argues that eventually, any civilization might realize that not much new was found from each encounter with other worlds. They experience what he calls cosmic habituation, basically galactic burnout. After a while, spending billions to send probes across space just doesn't seem worth it anymore. No Dyson spheres, no planet-wide laser beacons, no fleets of self-replicating probes. Just civilizations minding their own business, comfortable in their corner of the galaxy. Let's put this in perspective. The nearest star system, Alpha Centauri, is over 4 light-years away. With our current technology, it would take thousands of years to reach. Even with advanced propulsion, interstellar travel remains incredibly expensive and dangerous. Corbett's argument is simple. Why bother? If your civilization has already explored a few nearby systems and found nothing particularly groundbreaking, why keep going? It's like scientific burnout on a cosmic scale. You've sent the probes, analyzed the data, and realized that most star systems are just more rocks and gas. Eventually, staying home, developing your own society, and waiting for others to come to you becomes the rational choice. It's not that aliens can't reach us, they just don't see the point. So, what does this mean for our search? According to Corbett, we shouldn't expect powerful, deliberate signals beaming across the galaxy. Instead, we're more likely to detect weak leakage signals, accidental radio emissions from alien civilizations going about their daily business, much like Earth's own radio and TV broadcasts that leak into space. Corbett is optimistic that detection may not be too far off, historically speaking. Next-generation telescopes could pick up these faint signals within our lifetime. But here's the disappointing part. Even if we do detect alien life, it might not lead to any major technological breakthroughs. We could discover we're not alone in the universe, only to find that our cosmic neighbors are just as unimpressed with space exploration as we sometimes are. In Corbett's less terrifying universe, the galaxy might be teeming with life, just not the kind that finds us particularly interesting. It's a humbling thought. We might not be alone, but we might also not be special enough for anyone to bother making the trip. Space is big after all. Why not kick back, relax, and wait for them to come to you? What do you think? Is cosmic laziness the real answer to the Fermi paradox? Or are we missing something bigger?